You want to find the current that's being drawn from the battery. So that's the current here or here, which is the same. You don't want to find the current in either one of these branches. You can use Kirchhoff's law of junction and loop, but I wouldn't advise it. It's kind of difficult. There's an easier way of doing this. The way you would do it is just by saying I is equal to V over R equivalent. And that means you can basically just try to get the equivalent resistance of all three of these resistors into one so that you have a simple circuit and just try to find I using Ohm's law. So in order to do that, you got to figure out, or you have to realize that resistors in parallel will take on the equation 1 divided by this plus 1 divided by this quantity to the negative first power. So the inverse added invertedly, or I guess you could say the inverse of the addition of inverses is for resistors in parallel, and simple addition for resistors in series. First thing you got to do is take this branch and get it into one equivalent resistor. Then take that resistor and add it to this one right here. You can do this in one fell swoop by just being a little clever with your equation. I'm going to go ahead and just go from left to right. The first is 400 ohms plus whatever equivalent resistance comes from these two, which ends up being 1 divided by 500 ohms plus 1 divided by 700 ohms to the power of -1. And there you go. This is treated as a resistor. This is treated as a resistor in series. Doing the calculation, it's a pretty tough one. So I'd recommend you starting with the second term and then working your way back to the first term. We have 691.66, and it continues on forever, ohms. So I is then equal to V over R equivalent, which is equal to 12.0 volts, divided by 691.66 whatever ohms. And that comes out to be 0.01735 amps, which then we can go ahead and limit it down to 0.0174 amps to get it in line with the significant figures. So that's the current going through the battery itself.